Number systems, number 6, understanding irrational numbers. Learning target 4, I can estimate the value of an irrational number to the nearest tenth. In particular, we're going to look at square roots. So for example, the square root of 19 is approximately 4 4/10. And I'm going to show you how you can come up with this value without this calculator. So we are going to look at the square root of 5 as our first example. So step number 1, just like learning target 3, we're going to look at what two perfect squares this square root or the radicand can be between. So we can kind of narrow down where our estimate is going to be. So the square root of 5, well, I know the square root of 2, so 2 squared is 4, and the square root of 4 is 2, and 3 squared is 9, so the square root of 9 is 3. And if I think about this, the square root of 5 is approximately about right there. Okay, so if I look at this, I'm going to look at noticing that the square root of 5 is really close to the square root of 4. Not as close to the square root of 9, but definitely in between these two square roots. So that's step number 2, just like learning target 3, is we're going to write the square root of 4 is less than the square root of 5, which is also less than the square root of 9. And then step number 3 should look familiar to you. We're going to actually solve this. So the square root of 4 is 2, which is less than the square root of 5, which is less than, and of course, 3. Now, step 4 is where we become what we haven't done before in learning target 3. So step number 4 is what we're going to determine is which perfect square the radicand is closer to and estimate it to the nearest tenth. Now this is complete estimate at first. So if we look at this, and I've kind of alluded to this before, the square root of 5 is closer to the square root of 4 than it is the square root of 9. So, you're just going to kind of take a guess. So let's say maybe 2.2. Okay, so if we try 2.2, we'll say that's our estimate. Then you're going to come down here and you're actually going to square your estimate and to see how close you are to that radical. So remember that when we took 2 times 2, we got square root of 4. When we took 3 times 3, we got the square root of 9. So in this particular case, we're going to take 2.2 times 2.2. In other words, we're going to square it to see how close we get to 5 to determine if this is the perfect square. So we're going to try 2.2. Oops. Get rid of that. 2.2. So coming down here, just do some quick math here. So 2.2 times 2.2, and you can do this traditional, you can do this whatever method you use. You can take it 22 times 22 and then put it back in your decimals. I'm just going to do traditional multiplication here. So 2 times 2 is 4, 2 times 2 is 4, add a 0, 2 times 2 is 4, 2 times 2 is 4, and then I'm going to add, this would be 4, 8, 4, and then since there's 2 decimal places, I'm going to move the decimal over twice. So notice that we're going to get 4.4 as an estimate. Now that is pretty close to 5. Not bad, but a little bit underneath. So let's try 2.3 just to make sure that that is not a better estimate. Again, 4.84 is very close to 5, but not perfect. So let's try 2.3 times 2.3. Again, traditional math here. 3 times 3 is 9. 2 times 3 is 6. Put a 0. 3 times 2 is 6. 2 times 2 is 4. With our addition here, we got 12 and the 5. 2 decimal places. Going to add a decimal there. Move the decimal over twice. So yeah, now we went over top. So now we got to decide, which one is the better choice. In other words, which one is closer to 5? Because 2.2 squared equaled 4.84 and 2.3 squared equal 5 and 29 hundredths. And we're trying to get to 5. to make a better estimate. So if I look at this, I'll take this top one first. 5 minus my first estimate of 2.2 squared, and that's going to be equal to 0.16. So again, I'm just subtracting it to see the difference. See how far off I am from 5. So right now I am 1600ths off from 5. Let's check the other one. I'll put the bigger number first so I don't get a negative. 5.29 minus 5 equals 0.29. So 0 and 29 hundredths. Oops. So if you think about this, which one is closer to my estimate? Well, it's definitely this top one because this one's only 16 hundredths off, and the bottom one is 29 hundredths off. And 16 hundredths is smaller than 29 hundredths. So my better estimate between these two would definitely have to be the 2.2 right here because it got me to a closer value of 5. So right here I could write, I'm going to erase this a little bit so we can see it. We could write down here that we got 2.2 is less than the square root of 5, which is less than the square root of 2.3. But after we did our math and checked our differences, we noticed that 2.2 was the best estimate to the nearest tenth for the square root of 5. Okay. Next example, square root of 13. Square root of 13. Well, let's see. 3 squared. We'll start with that on the number line. 3 squared was 9. So square root of 9 is 3. 4 squared is 16. So the square root of 16 is 4. And square root of 13 definitely, we'll put it right here, falls in between those two. So we pick the correct whole numbers. So we'll do step number 1 here. What two perfect squared are the radicand between? I should say is the radicand between, which would be 3 and 4. Or the square root of 9 and 16. So they want us to set up an inequality here. So the square root of 9 is less than the square root of 13, which is also less than the square root of 16. Now, if we actually solve those, again, these are the same steps we went through in LT1. We're going to solve them. So the square root of 9 is 3, and the square root of 16 is 4. So again, I'm just solving right here. So that gets me started to determine what I should estimate at. So let's see. Square root of 613. I do a little division or a little subtraction here. That's 4 away. If I look at this, this is 3 away. So it's not close to one side or the other. Closer to the 4 than it is to the 3. Let's guess 3.6. It's not halfway in between. It's a little closer to the 4. So 3.6 is going to be my determination of my estimate. So 3.6. Okay, and again, if you pick 3.5, that's fine. If you pick 3.7, that's fine. I'm just going to guess 3.6 just because of how far off the square root of 13 is from the square root of 9 and the square root of 16. So we're going to pull this down. Okay, so now we have to actually square it to determine where we're at. So 3.6 times 3.6. So 6 times 6 is 36. 6 times 3 is 18, plus 3 is 21. Add your 0. 6 times 3 is 18. Carry the 1. 3 times 3 is 9, plus the 1 is 10. I'm going to pull down. I get 6, 9, 2, 1. 2 decimal places, so I'm going to move decimal over 1, 2. So I get 12 and 96 hundredths. Not bad for 13. I'm going to guess that's probably the closest, but just to be careful and to be okay with this, I'm going to try 3.7. So 3.7, and again, I go up to 3.7 because this is low, and I'm going for 13. So 3.7 times 3.7. So 7 times 7 is 9, carry the 4. 7 times 3 plus 4 is 25. It's 21 plus 4 is 25, 0. 7 times 3 is 21, carry the 2. 3 times 3 is 9, plus 2 is 11. So 9, 6, add is 3, bring down the 1, move the decimal over twice, and we get 13.69, or 13 and 69 hundredths. Let's check which one's closer. So we're going to take the first one here, and we're trying to get 13, remember, by squaring 3.6. So 3.6 squared equaled 12.96, and 3.7 squared equals 13. And I don't have to try anything else because 13 falls in between these two values. If I still hadn't gotten to the high end of 13 and the low end of 13, then I would need to try another tenth. But since I'm in between, I can check these. So I'm going to check here. And again, remember, I'm just going to subtract to see which one's closer, even though I can pretty much tell here that this one is the closer value. So 13 minus 12 and 96 hundredths equals 4 hundredths. And 13 and 69, oh, somehow that changed on me. And 69 minus 13, ooh, my computer's going wacky on me. 13 equals 0.69. I'll put that back up here since I decided to go spazzy there. Okay, so I have 4 hundredths and 69 hundredths. Well, mathematically, of course, the 4 hundredths is a smaller value, which means that 3.6 is the closer estimate. So we're just going to fill in this last line here. So we had 3.6, and notice that we keep just making this even more detailed. We went from whole numbers, now we're going down to tenths, and if we wanted to, we can go do this to the hundredths, to the thousandths, but we're only going to do it to the tenths, so no worries. So 3.6 is less than the square root of 13, which is less than 3.7, and then after we did our difference here, we know that 3.6 is the better estimate. So that is our final value. That's my smiley face to show our better estimate. Next problem. So example number 3. Last example here, we're going to do the square root of 22. So number line again, because this is the way I start thinking. Let's go 4. 4 times 4 is the square root of 16. And then 5 times 5 is the square root of 25. Oh, I'm already between the square root of 22 is between these two values. I'll put that around, let's put it about right here. So let's go through our steps. And again, as you start to get used to this, you can start being more efficient. You don't have to go through each of these 5 steps, but these are the 5 steps your brain should be going through. So I can say, which two perfect squares is the radical between? It's between the square root of 16 and the square root of 25. That's what I'm going to write down here. So here's my inequality to prove that. The square root of 16 is less than the square root of 22, which is less than the square root of 25. And then I'm going to solve. So square root of 16 is 4. The square root of 25 is 5. And again, remember, all these steps was LT3. So those should be nothing new. Now we're going to determine. So I'm going to go back up here again. So my square root of 22, if we look at this, it's between, there's 5 spaces in between here. So there's 5 spaces. I don't want that to bug you, but 5 spaces in between those. And then over here, there's only 3. Well, 3 is much closer than 5. So it's got to be on the high end or towards 5. And it's not half, so it can't be 4.5. So that probably wouldn't be my best estimate. So I'm going to check. Let's go. It's not far off. Let's go 4.6. Again, if you picked 4.7, fine. If you picked 4.8, that's fine. As long as it's between 4 and 5, you know that's the two whole numbers it's between, you get to decide what you want as your estimate. I like to try to predict as close as I can because that means it's less multiplication I have to do to prove it. So I'm going to check my math. So 4.6 times 4.6. In other words, we're going to square 4.6 to see what I get. So 6 times 6 is 36, carry my 3. 6 times 4 is 24, plus 3 is 27, put my 0. 6 times 4 is 24, carry my 2. 4 times 4 is 16, plus 2 is 18. And then I'm just going to do my addition. I get 6, 8, 9, 10, 11, 3, 1. Something went wrong. I must have did the math there wrong. Oh, that's a 2 and 8. Whoa, 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 back up. Let's erase that here. Whoop. The big erasure. So let's put this back. This is a 2. This is a 7. This is a 0. This was a 4, 8, and 1. All right, let's add again. So 6 plus 0 is 6. 4 plus 7 is 11. Carry the 1. 8 plus 2 plus 1 is 11. Carry the 1 is 21. Much better. So move the decimal over twice. 1, 2, since there's 2 decimal places up here. So I get 4.6 squared equals 21 and 1600ths. Not bad, because what I'm going for is 22. So am I low or high? Well, of course, right now I am low. So the best bet is to check 4.7 just to see if I can get any better estimate. So we're going to take 4.7 times 4.7. My traditional math here, again, do it however you are more comfortable with. 7 times 7 is 49. 7 times 4 plus 4 is 32. Here's a 0 for holding my place value. 7 times 4 is 28. Carry the 2 this time. 4 times 4 is 16 plus 2 is 18. So adding 9, 0, carry the 1. We're going to get 2, actually 12, carry the 1. 1 plus 1 is 2. Move the decimal over twice, and I get 22 and 900ths. So I'll record that over here just to keep everything straight. So remember, our goal was to get to 22. We're looking for the square root of 22. So in other words, what times what? You want to think of it that way. Squared equals 22. Well, you can kind of already see, 22 would fall between here. You can already see that we are correct. We have our two bottom, our lowest estimate and our highest estimate. So I could actually fill this in if that helps you. Okay, now I got to determine which one's closer. So I'll do a little math here. 22 minus 21 plus 0.16 equals 0 and 84 hundredths. Okay, not too bad, not great. We're going to check this one. 22.09, so 22 and 9 hundredths minus 22 equals, well, this one is only 9 hundredths away. So looking at this, looking at math, this is a much smaller difference. So 4.7 is my best estimate. So 4.7 squared is the best estimate. I should probably put this as a approximate symbol, is almost 2.22, closer than the 4.6. So I'm going to write with 4.7, put my smiley face because it took a while of work to get there, is my better estimate. So I want you to pause the video and do example number 4 by yourself before you watch my steps. So the square root of 7. So let's think about this here. Square root of 7. Number line. Okay, here would work for me. Well, square root of 9, I'll go backwards here, is 3. And the square root of 4 is 2. and the square root of 7 falls in between there. So I know I'm looking at the whole numbers of 2 and 3. So in other words, my estimate for the square root of 7 is between these two values. So I'm going to walk through my steps here. What two perfect squares? And I solve that by up here. Square root of 4 and the square root of 9. I'm going to write that in my inequality. So the square root of 4 is less than the square root of 7, which is less than the square root of 9. Totally a true story. Solving it, we already kind of did that with my diagram up here. Square root of 4 is 2, and the square root of 9 is 3. So the two whole numbers that the best estimate for the square root of 7 is between 2 and 3. So I'm going to go back up here and look at where the square root of 9. So if I kind of look at this, this is 3 between, this is 2 between. It's not, it's particularly closer to the 9 than it is to the 4. So it's not half. I always kind of like to do that to see which half of it's on. So it's definitely on this side. So it's above 2.5 on this half. I'm going to estimate 2.6. It's not too far from 9. It's not great. I might be too low, but we're going to check this out. So 2.6 is going to be my estimate. Again, that can be anything you want it to be. Well, not anything. It needs to be between 2 and 3. But using that idea of is it over the half or which one is it closer to really helps you do less work because you will guess less times of how many tenths you have to guess between. So 2.6 times 2.6, and our goal is here to get to 7. Remember, that's our square root we're looking for. So 6 times 6 is 36. 6 times 2 plus 3 is 15. Add my 0. 2 times 6 is 12. Carry my 1. 2 times 2 is 4 plus 1 is 5. I'll work on my addition here. 6, 7, 6. Move the decimal over twice, and I get 6 and 76 hundredths. Not bad. Close to 7. Not perfect, but close. Let's record this. So 2.6 squared was 6.76. So since I'm low, I'm going to try 2.7. That might be a better estimate. Let's switch colors. There you go. All right, let's try this one. Going through the math again. 7 times 7 is 49. And 7 times 2 plus 4 is 18. Add my 0. 7 times 2 is 14. Carry my 1. 2 times 2 plus 1 is 5. So we have 9, 12. Carry my 1. That's 7. So I'm going to move my decimal over twice, and I get 7 and 29 hundredths. So 2.7 squared is 7 and 29 hundredths. So good news, I have my low end, I have my high end. I don't need to test anything anymore because I know it has to fall between. Now I just got to decide which one of these two is closer to 7. So I like to do my subtraction or my difference. So 7 minus 6 and 76 hundredths is 24 hundredths away. It's hard to see there. And then I'm going to try this one. 7 and 29 hundredths minus 7 is 29 hundredths away. So this one's actually pretty close between these two. But since this was 24 hundredths, I'll rewrite that since it's hard to see. 24 hundredths is actually smaller than 29 hundredths. So this 2.6 is my better estimate. So I'm going to fill in my blanks here. So 2.6 was my low end. So that's less than the square root of 7, which is less than the square root of 2.7. But after doing my differences, I notice that 2.6 is my better estimate because that is closer to 7 than the 2.7. I hope this helped you. Have a good day.